Hello everyone, my name is Davor Sauer. I'm software architect at the Backbase, and today we will talk about putting our head or your head in the cloud. What is this? Everything okay? Okay. So, what is idea about the cloud today, and what we're trying to achieve? The main topic is about traditional deployment and the cloud deployment. And most customers today, they want to migrate to cloud. And what we want to provide them, it's actually ability to do that some kind of easy way. So if they have already existing platform, they want to have some kind of possibility that they can plan that in the future to migrate in some kind of small phases, not directly switching to the cloud and turning off everything and moving on. So this is about how we can build the platform, or more or less our experience or my experience, how we can enable to build that kind of platform for a customer that can enable them some kind of phase migration from what they have at the moment, more or less that's on-premise deployment with some web spheres or enterprise environments that they want to move easily, granularly to the cloud. What we'll talk today, it's about some introduction, more about the topic. What is actually the problem? Here we'll mention more about the problem itself. What are the key differences between those two approaches? And of course, how and what is the goal, and how we can achieve that goal. And on the end, we'll compare some key differences between the traditional deployment and the cloud deployment. And also on the end, I will show a small demo because this is something that I'm working at. And the demo will be showing something like application in Tomcat and also application on the cloud. At the moment, it will be more in-depth about Cloud Foundry and how we can leverage on top of that platform, which is also some benefits for the end user. So, about putting our heads in the clouds. So, for the most customers, this is a journey. And what we're working at the moment, at least in my company, it's with the banks, so it means that they're more or less, not all of them, they're behind, but they want to move to the cloud. And they already have existing platform, or they want to use the product which can enable them to move to the cloud. And yeah. Moving to the cloud for them, it's not easy. So they have all the equipment that they have now. So what they want, they have a bunch of machines. They have data centers already built for everything. And for them, the cloud is really unknown. I remember from previous company I was working for them, cloud was something totally unknown, and always was idea, this is public cloud, I need to deploy somewhere where everyone can have access. But this is not true, as we know. And with some of the solutions that I will show today, it's possible to have a private cloud, and it's always possible with today's technology to have some kind of isolation in that level. So in most cases, we have already some starting point. That starting point is existing platform that we are already working with. And that platform enables us to have some kind of flexibility. In most cases that we have those days, we dealt with a monolith. And that monolith was something that we provide the customer, that the platform itself that we provide is flexible, which means that they can easily actually extend the platform, so they can actually build the new functionality on top of existing, or they can actually extend existing functionality and put extra flavors on top of it, which is not a really easy task when you take a look, because if you have existing functionality and you want to have closed product that you want to have control, but also you want to have the customer possibility to change something there. For example, you have some service that is working with transactions, and you provide, for example, username and first name and the last name, and then they want to use the middle name in the between. So you need to provide flexibility that they can actually add extra flavors. And what is happening with most cases, what I faced in the last 7 years, first approach that I saw, the company was shipping actually source code and couple libraries as a part of the platform. And then you have some kind of box that customer actually can put extra flavors into it. And then on the end, after they add some flavors, they can build that big monolith, and they can work with that. Another approach that I saw, the company provides like backbone for everything, also with some of the libraries. And then the customer add extra flavors inside. It's interesting, if you're using, for example, Spring, then you really have a lot of flexibility. It's basically a loaded gun, so you can override any kind of bin. So you can actually screw up the platform itself because you're actually in the domain of the platform. As you can see, the customer can also add custom libraries. So you can already notice that there is a problem with dependency hell. You have some libraries that you have, and the customers wants to add some extra functionalities with their custom libraries, or some libraries with different versions. So it's getting messy there. It's a similar situation with the code base, because you want to extend some functionalities that is already provided from the platform, or you want to add new functionality, which is maybe less problem. But then you are mixing everything together, and when you give that to the customer, and after a couple months in production, for example, you start to face some problems, and you don't know where are the boundaries, where is actually the platform code that you provide, or the functionalities of the code that you provide as a part of the platform, and where is the customer code that actually interfering with your platform, or overriding something, or extending something. And in this part, I think those days, what we want to achieve is to have some kind of harmony, because it's a really messy picture when you have the platform and custom code inside, or custom libraries. And with Java, it's also easy to add a custom library to the class path, and Spring will actually luckily take everything from the class path and load what you define there. So you really need to provide proper isolation, what is there and what is loaded, because you want to have this kind of harmony, that you know what is your part of the platform, what is your part of the product that you are shipping as a functionality somehow, and where's the boundary that customer have something that you know, okay, there is a problem, and in the case of the problem, we know that this is your implementation problem, or is it our implementation problem in the platform, or in our functionality. In those days, it's quite a popular topic in the last 2 years. We have microservices, and there's always, it's a hip, and everyone is trying to do something with that, because some companies succeed with that, and they're happy with that. Some of them, they're trying to do that, but main idea behind microservices, in this case, they need to be applied properly. And in this case, when we want to achieve this kind of harmony, it seems like a reasonable approach, because we get for free that kind of isolation. Idea of each microservices is that it's independent. And if each microservice is independent, means that actually, if they want to add a new functionality, we still have that flexible platform that customer can add new microservice in the bundle. And if you have proper architecture around everything, new functionality will be added without interfering with other. In the case, if we want to extend the current functionality from the current platform, in our case, that's a banking software. So we provide our bank out of the box, and you have some services for some banking stuff, and they want to reuse that, of course, because it will give them fast kickstart. But they always want to add extra flavor on top of that, something that they want. It can be front-end, it can be back-end. It's always some kind of functionality. And for that, what we saw is a good approach, and it's also maybe good advice to have separation between the private and public APIs, because public APIs is something that they can reuse, they can actually tap into the system. It's some kind of hook for them. For the private ones, I would advise you to keep behind the scene for you, because this is something for the platform itself, something that you can change on each version of the platform, and then your services or your platform can breathe as is without interfering public interfaces and interfering with the functionality of their system. So the migration itself will be much easier. When you're doing that kind of platform that it's really highly flexible, and that you want to have that really clear boundaries. Also, one way to have the hooks, it's also with pub/sub messaging, and means that each service that you have can emit some kind of events, and if customers want, they can actually listen for those events and build the functionality on top of those events. It's maybe not synchronous, but if you have that kind of huge system, you're actually aiming for asynchronous events, which means that they can build the service which can interpret the data and later on send the information to the end user. And what you also want with the services, and I think we saw something similar, you want to have them stateless. You don't want to have the shared session or shared context between two services. So you are forcing yourself, when you're designing the platform or architecture around the platform, to be really stateless. And all the flows are, sometimes it's really hard to go around some parts, because when you take a look at the platform, it looks like classical microservice approach, but you have some limitation here. And it's a limitation, but it's also constraints, because if you take a look, for example, how Netflix did, or Spotify, they all of them, they have the gateway on top, and in Netflix case, they have quite enough logic in the gateway, I would say. All the Zool stuff that they invented, it's actually a bunch of filters that contain some kind of not strictly related business logic, but it's more like platform infrastructure logic, where to route traffic and what to pass to the service and how to aggregate. And when you come to the customer, which is already paying for some kind of gateway, and they have the license for maintenance and everything, and you tell them, there is our platform, there's a gateway on top, and then they say, okay, why we need another gateway? We're already paying for a gateway that is doing all the things that we need to do. But the gateway is actually a gluing component between all those microservices, so it's entry point to the whole system, to the whole platform. And one advice or is try to call that gateway differently. Try to call it like a routing service or edge service, because if you sell the gateway, it's end story already. And if you're aiming for having the gateway, try to not to put too much logic into it. Try to have some lean, small gateway that is doing really basic things. And this is one of the impact of that kind of building that kind of platform, because in that case you're pushing all the logic down to the services itself. And it's not pleasant to build 50 services with, let's say, 20 libraries that it's shared between all the services with those common capabilities which can be easily built in the gateway, just because there is a possibility that customer will want to replace your gateway with their gateway, with their own gateway. So this is one of the impact, or if you're building the platform that you want to sell, because if you have the microservices in the house, then that's fine because you're not selling that to anyone, and you have all the freedom that you can choose where to put the logic. It's really nice. Another freedom when you're building the platform in the house, you have all the freedom about choosing the right technology for that. For example, if you want to use the messaging, probably you will use Kubernetes or something similar. And if you have that kind of restrictions on the platform that you want to give to someone or sell to someone, then when you face almost to the production, they will ask, where is enterprise support for that kind of messaging? And you say, oh, we don't support that. I mean, we don't provide that because it's not our domain. Then they get in the problems because the license for that kind of enterprise support of some of the platforms, it's not really cheap. I would say advice here is try to rely as much as possible on the interfaces or on the standards, and try to be more transparent or generic what you want to use as a technology. It can become painful because you need to provide advice. What is advice to use, for example, for the messaging? And then, of course, if you're providing advice, you need to also test all that. And if you have, for example, you are transparent to the database, you don't want to use just Oracle, you want to provide support for MySQL, for Postgres, then you need to test on all of this because you need to run all the tests on all combinations. Then you put in combination messaging broker, then you have multiply combinations of what you want to verify. So in this case, the testing, actually automated testing, it's most crucial, important here, because you want to have automate everything. And when you release that kind of product, for example, if you have product in the house, you release it, you merge it, you push it to the pipes, and ends up into production. That's great, that's fine. It takes maybe 20 minutes. When you want to test on 3 different databases or 3 different messaging and all combinations and different features of the platform, then this becomes really time consuming, which is not happy flow. And you need to think about how to automate this. One way is that you always test on early phase as much as possible. So to provide as much possible unit tests, integration tests, also component tests between the services. But when you reach to the combination of different database providers, messaging brokers, then maybe advice could be to test that on the end, because then you assemble everything together, and then if there is something failing, then you can easily see what is happening, because this is not going directly to the production. Because if you have the platform, this will be part of the release, maybe that day or week after. And taking account the banks, that takes time. If you have a release every day, they cannot easily upgrade every day. It will be ideally, but we're not there. That's the reality. And there's always some kind of mediator in between after you release. You need to have all the release notes, what is released, and then you ship that to the customer. They verify is it actually working, and then they have their own pipelines to verify is the platform actually working as expected for them. So for them, it's also not easy goal, because if you have platform that you're shipping to each customer, that platform also needs to be tested on their environment. Also, all the automations. If you have the product in the house, you build automations once and you're fine. Everything is working. It's easy to upgrade. If you're selling the platform to someone and you have 10 customers, all of them, they need to implement again all the pipelines, all the workflows for the testing. And there's not much you can do there, because they always put some kind of custom things there that they need to test as they want. Another impact on that kind of flow, when you're pushing all the stuff to the services down below the gateway, it's also security. Usually when you build the services, you don't want to build the service for each customer differently, because they use different database, and then you pack different database driver inside. And of course, you're not allowed to do that because you don't have the Oracle license, for example. So they need to provide you some drivers, for example, on their environment, but not in yours. What you want to do is to build the services as a black box. So you don't want to give them opportunity to open them, to change something inside, because this is your property. And in that case, one way that you want to deal with this situation is that you have some kind of common libraries that you share with all the services. And in that way, you're actually sharing all the common attributes. And authentication is also specific because each customer, at least from my experience, each bank, they have their own custom implementation or tune-up of security. Most of them those days, they use OAuth 2, if you are lucky. Some of them, they use SAML. Some of them, they use some totally different stuff. They produce their own GVT tokens with custom claims. So it's always something custom. Even if you have the same, let's say, OAuth 2, they always add some extra information inside that you need to somehow propagate to their system. In most situations, if you have a platform with existing functionality, which is a green part here, you provide some kind of integration services that they use to integrate your system with their legacy system. And this is actually the area where you're actually joining the business logic between your platform and their existing system. And in this case, authentication service is used to actually integrate their custom token and translate that into something that is already well known for all your services. Which means that, for example, you can say all our services, they're using specific type of JSON web token, and all what is outside, it's actually pluggable, which means that customer can actually easily integrate that into and pass information to your system, and then use your system transparently, regardless what they have outside as authentication. They just need to follow some basic guidelines. In some cases, they integrate with LDAP, Active Directory, some kind of OAuth 2 system outside, but the transport protocol of information, it's always different. I never saw two banks or two customers having same token, same information with same structure. But if you go into that direction and you put that restriction to them, I think that's also not a good way, because you want to give them the flexibility. And this is what they aim for, because they want to have flexibility to build whatever they want to do. And they want to reuse what you're actually shipping as a platform or as a functionality built into the platform that they can easily kickstart and reuse it and move forward more fastly, of course. Common approach those days, if you are in Java world, it's with a Spring Boot. And one way, it's in most cases reusing networks libraries to build the microservices and all the things around. There is still possibility that customer will want to have something different, for example, that you have as a technology. So you need to be aware of vendor locking. Most of the Spring Boot stuff, they're using networks registry. But with Spring Cloud, you are more transparent, so you can use the different type of registry, which is giving them more flexibility. Another idea that it's, as I mentioned, it's to have a lean gateway, so you don't have much logic there. So if there is really need in the future that you want to replace the gateway and put that to the customer into their gateway, because they don't need to maintain two gateways, if they are more or less afraid of the naming and what is doing, then it's good to have the clear contracts what the gateway is doing and how it's doing. I don't advise you to put that into the public documentation, because this is more or less not good for security perspective. It's also same for the security when you have tokens, JSON web tokens. From my experience, they always ask what kind of claims do you have, what kind of encryption is used. what kind of data you store into your internal token. So be aware about disclosure, what you are actually showing to everyone or what you're showing to the customer or specific security advisor in the bank, because this is something you don't want to easily let it go. And of course, as I mentioned before, there's a common libraries, and this is a good way to share the common features that are on top of each service. So something that all the services share together, which in most cases it's some security. From my experience, we are using this to build custom Spring security filters just to intercept the token and authorize the user. There's others cases with the Spring Boot that you can do that, and with the common libraries, because, for example, you want to provide the parent starter, for example, for authentication service, because you don't want to have a written down contract. It's much easier to provide, for example, a Spring Boot parent starter that they can build authentication service. So they build just one or two classes that doing exchange between their services and your service. And if you give them opportunity to do that manually, then it becomes really painful because you need to take care of each variable. So try to provide interfaces with Java is that quite easy. And after you finish with everything, then finally we are coming to the fact how to enable the transition between traditional deployment and the cloud deployment. In the banks or in some customers, they already have all the mainframes and data centers, and they're already paying license, for example, for the WebSphere or JBoss or other enterprise solutions, and potentially they will like to move to the cloud, not just because it's hip. It's also because it's much easier to scale up. So there's other benefits that we can get from the cloud deployment, but that involves a lot of infrastructure. And if the customer is already in the phase that they want to do that, but they're already using your platform, and easy way to enable the customer to do that, it's if you have the platform which is prepared to do that phase migration, so they can choose when and how they can actually easily migrate. So they have all the time, all the opportunities to how to do this. Important, or maybe not just important, the key difference between the cloud or microservice approach and the traditional deployment, it's a class path. If you take a look at a regular Spring Boot microservice, all of them with embedded Tomcat or Netty or whatsoever, they run as a root application on the different ports. So if you scale multiple services, they will just start multiple services on different ports. And that's fine. That's how the microservices are working. With traditional deployment, you don't want to deploy 50 WebSpheres just to spin up one application, or that heavily change their existing setup that you want to configure what WebSphere to start multiple applications on different ports as a root application. And there's no support from the Spring Boot or from Netflix for the context path. As I said, this is not how microservices are working. So with those common libraries, as I mentioned before, this is easy way that you can actually put extra flavors on top of each service, that you can provide information, for example, to the registry, where all the services are registered together, and then you can easily leverage that information that you can tell the gateway, okay, those applications that deployed as a traditional applications, let's say, and they live on this different context path, which means when you're doing the routing, which is the basic functionality of the gateway, you easily can inject that into the request. And another point from microservices, it's not advisable, but there is always a situation when you have the service-to-service communication. I mean, we cannot easily avoid this. We can do that a bit later or plan how to reassemble the logic and find the better boundaries between the services. And one way with the Spring, there is easy way with REST templates and interceptors. So you can produce custom interceptor which can actually inject the custom context path of the service which is called, and then that way also enable transparent deployment. The thing with context path is that when you register the service, the library or service itself will register itself and also pick up the context path that is deployed on, and then send that to the registry, and everything will actually be propagated. With this functionality, you're giving actually the customer the flexibility that they can actually have already a couple services in the cloud deployed as a root application, for example, and also some of the services deployed as a traditional. So you really have all the flexibility how you want to define your deployment topology, which is, I think, quite a huge value. It's a small change, that's true, but it's giving the customer a huge value that they have flexibility, they have the chance to do what they want to do when they want to do. Another thing, next to the context path with microservices, it's of course configuration. That's a bit painful when you have 50 or even more microservices, and when you have traditional deployment, you always configure one application because you have 3 of them and all application is in one file. With microservices, this becomes really a nightmare because you don't want to configure 50 property files, slightly different. So you want to have some kind of centralized place to do that, and good place for that from Spring, it's Spring Cloud Config, which enables you to have all configurations into at least one folder or one Git repo that you can actually tell all the services. Configuration is there on one place, and good feature is that you can tell the services wait for the Cloud Config server to be available, because you want to have in which state your service is actually starting. You don't want to start a service relying on Cloud Config and using default configuration. Then you really don't know what is happening there. And then after you have some prepared platform that is actually can work on the cloud, one of approaches, there is a lot of those days there's a lot of different cloud providers, but one of interesting one, I would say, it's Cloud Foundry. The key benefit is it giving you everything out of the box, all the management, all the things that you expect from the cloud in one place. And you also have transparency of infrastructure. You can deploy it on the Amazon, on the Google Cloud, the Azure also. So more and more is coming as a layer that you can actually put the platform on top of it. Cloud Foundry can be also installed on the premise. So if you have the data center, so there is a possibility that you can install it there. That's not an easy task, to be honest. And the platform itself, it's quite heavy, but it gives a lot of possibilities that are pre-built inside. All the expectation from the Cloud Foundry, it's actually that all applications are actually 12-factor based applications, plus 13-factor, which is the health check, and which means that all the services that they're inside, you can configure them to the environment. And how Cloud Foundry is enabling you to do that, it's through one manifest file that you can describe which services you want to push to the platform. And then this can be also one place of configuration because it's one file, and you can also unify configuration. There is a lot of out-of-the-box services provided from the Cloud Foundry itself. There is also messaging. This is internally, but there's other services like RabbitMQ that is coming out of the box and supported. You also have log aggregator, so you can see all the logs from all the services at one place. You don't need to visit all the microservices separately to see what is happening there. On top of each service, you already have the load balancer, so you don't need to think about having some extra installation of some load balancers. And interesting part from the Cloud Foundry, it's the actually self-healing. It's a quite cool feature that if service goes down for some reason, the Cloud Foundry will start the same instance again, or of course, like most of the cloud providers, it will actually automatically scale or scale down the number of the services that they're under the pressure. If you're interested, it's a really interesting platform, and I advise you maybe to take a look at that. And for the demo, there is a two small demo. First demo will be about the, let's say, traditional deployment, where you actually have something to one application server with, in this case, with 5 applications, and all of them they are in. They have their own context path, so you can actually access them directly. So let me show that. Okay, this will be a bit tricky. So at the moment, oops. We have the gateway, which means that gateway is not deployed as a root application. That's the tricky part. If you have multiple applications deployed on the one Tomcat or one application server and you deploy one as a root, then the routing itself, the first step of the routing will be done by application server. So if you want to access some application with different name, it will go to that application, not through your gateway, which knows where to route. So this is one of the foundings. This is just an example that gateway is actually healthy. But one example is that we can actually access, for example, authentication service directly, which is not something that you want to expose directly through the web. I mean, in most cases, you always have some extra gateway or some kind of extra security check on top of the platform itself, like entry point to the whole banking system. So that's the place where you want to filter out that kind of things. Or you can configure the application server not to expose this, which is not the most common way. What you want to have, it's to be able to access the services through the gateway. And this is the case, for example, this is just a simple login. Oh, I think it's not registered. Well, meanwhile, we can just show this one is also under context path. Seems Tomcat's down. Okay, my apologies. But the main idea is that if you have one application server, you have direct access to all applications, which is not something you really want. And you always want to have traffic routed through the gateway, because if you have some phase migration and some of the services are already in cloud or in different network domain, then the gateway will know based on the registry where to route the traffic, not the application server that is actually facing front to the end user. In the case of the Cloud Foundry, this situation is much better, because this is local development, so build a Cloud Foundry for the local development, so you can spin it up on local machine. just be aware it takes a lot of memory and a lot of disk space. So, and as you can see, some of the services like service A, authentication, they don't have the route, which means that you cannot access them directly. So the platform itself is already providing some kind of isolation, which services are available and which services are actually directly exposed to the end user. In this case, this is the gateway and small workaround just to have the registry available for everything, because there is also registry, Spring Cloud Networks registry, Eureka, available from the Spring as a service in the Pivotal Cloud Foundry. And in this case, this is just a registry which is on the local PCF development, and this is our gateway routing traffic to the authentication service on the Cloud Foundry itself. We already saw that the routes are not available, so you cannot access to that authentication service directly. Just forgot that. This is actually topology on the Cloud Foundry. As you can see, there is multiple layers that Cloud Foundry is providing. On top we have some kind of routers. There is also possibility for the customer or for you to change or add extra flavors to each request. They provide their own authentication. This is to log in the user and similar things. App lifecycle. So this is the core component of the Cloud Foundry, which will give you the possibility to automatically scale up, scale down the services, or self-heal the services. Self-healing is also important because that's the 13th factor, so-called, from 12-factor applications, which means that it's using the health check of each service to see is it healthy or not. So the health check itself that is provided with Spring Boot actually is quite important here, I would say. And as you can see, the topologies, how you deploy your services, it's more or less the same. Only the workers, they're not exposed in this situation. And in the previous slide, there was similar topology where you have all the services and the gateways or routing services doing the routing to a specific service. And in this case, you're giving that extra flavor to the customer, how they can do that phase migration between on-premise or traditional deployment to some kind of cloud deployment. With Cloud Foundry, you get really extra stuff, and there's a bunch of the services that they provide out of the box that you can just download from the marketplace and use it as is. So there's no extra installation steps there. And for almost end, the key takeaways. As I mentioned before, the key thing here is context path. So it's not a lot, but it's something that it really gives the value to the platform that is flexible. Second, of course, the microservices. It gives you clear boundaries, and if you have the proper documented public and private APIs, REST APIs, and events that the platform and your system is sending around, it gives the customer possibility to easily extend what you have and build on top of that. Not just to build this bunch of the services, also extend the business values from the services that you already provide as some kind of starting point of the business values. When making platform that kind of way, the communication with customer is also important, because you need to make clear what is what. In case with the gateway, they need to be aware what is the gateway for our term, because in our term it's just a routing service, but in their mind they think gateway is a full-fledged API gateway when they have API management, all the things, which they are already paying for it. So just be careful there if you're doing something like that.